Here I'm giving you an introduction to simple harmonic motion, and we'll look at it in detail and try to understand exactly what it means. To begin with, let me say a couple of things. One is simple harmonic motion is an example of oscillatory motion. And I'm sure you know what oscillatory motion is. An object which is, for example, a pendulum. Let us say this is a pendulum and it is moving around a mean position, going in this direction, then coming back to the mean position, then going in this direction. So this is an example of oscillatory motion, and simple harmonic motion is an example of oscillatory motion, or what is known as vibratory motion. 2, it is periodic in nature. That means the time taken for one oscillation remains constant. So if it goes over here, comes back over here, goes that and comes back, one oscillation would take a fixed amount of time. So this is the background of simple harmonic motion. It is oscillatory in nature and it is periodic in nature. Let us try to understand what do we mean by the term harmonic. Sometimes simple harmonic motion, SHM, is also called a simple harmonic oscillation. So now let us focus our attention on trying to understand what harmonic motion is. Basically, harmonic motion means that this particular motion obeys or follows the sine or cos function. In trigonometry, you would have studied sine function and cos function. Let us say for example, y is equal to sine x. And if I plot a graph of y versus x, I'll get a curve something like this. So this is y and this is, say for example, x. So if I look at this closely, I can think of this as a particle performing to and fro motion, oscillatory motion. For example, it is going in this, if I consider this as the mean axis, this is the mean position or the mean axis. The particle is going in this direction, then coming back in this direction, going over here, going back over here, so on and so forth. So it is performing oscillatory motion. And if the vibratory motion, say for example the case of pendulum or any other vibratory motion, obeys this particular law, y is equal to sine x, then we call it harmonic function. The important thing to note over here is that this particular function has to be a single harmonic function, a single sine function or a single harmonic function. Meaning that there has to be only one function over here. I'll give an example of what is not a harmonic function or what is not a single harmonic function. For example, you could have equation y is equal to sine x plus, say for example, sine 3x. Now this has two functions in it, so this would not be an example of a simple harmonic function. Okay, so I hope now you have got an idea about what is harmonic motion. It has to follow the sine or the cosine function. Just for the sake of revision, a sine cos function would look something. It would start from here and it would go like this. So this would be an example of a cos function. So if it is either of these two, if either of these two equations is followed, then we call it a harmonic function. Let's now focus our attention on the word simple. When we say simple harmonic function, it is a harmonic function in which the amplitude is constant. In this case, you know what amplitude is. Amplitude is the displacement from the mean position, the maximum displacement from the mean position. So this particular distance, the maximum displacement from the mean position is amplitude. And if that remains constant throughout the motion, then we call it simple harmonic function. That means this distance, if it is, say for example, 2 centimeter, then this would also be 2 centimeter, this is 2 centimeter, 2 centimeter, 2 centimeter, so on and so forth. In that case, we call it, the amplitude is constant, and we use the word simple harmonic function. Because we could also have a function like this, we could have amplitude varying, things like that. So if in this case the amplitude is not constant, it's varying, and then we would not call it simple function. It may be probably harmonic, it may be oscillatory motion probably, but it is not simple harmonic function. So the graph of the simple harmonic function should look very uniform with same values of a, throughout. This distance would remain constant. So that is what simple harmonic function means. To summarize, it has to be oscillatory motion, it has to be periodic in nature, right? That is also it also means that it has to have a single frequency. Right? Third, it has to obey sine or cos law. Coy's function, and finally it has the amplitude has to be constant. And so this is how a simple harmonic motion is understood. A final point is the equation y is equal to sine x could also take the form y is equal to some constant a sine x. This would also be an example of simple harmonic function. In this case, this a would represent the amplitude of the sine wave. Right. So we have discussed simple harmonic function, simple harmonic motion. In the next video, we will look at the force that comes into play. Because as you know, in this case, when this is going in this direction, its velocity decreases, and that is because there's a force, there's a damping force which comes into play. So we'll try to understand what this force is all about and what are its characteristics and what is the acceleration of this object while it is performing simple harmonic motion. Thank you.